Good day, folks. It's Tony Fortunato from the technology firm. I'm going to walk you through some tips, tricks, and all sorts of cool stuff in a multi-trace analysis. The most important part of your multi-trace analysis is going to be your documentation. So make sure you take a few seconds and draw out your network, test points, test equipment, and in this case, MAC addresses. So I've got the MAC addresses down here of the firewall, the inside and the outside, or internal, external, however you want to say it. I've got a MAC address out here on the internet. That's good to know. And I've color-coded things depending on the Ethernet adapter I've used to capture from this laptop. So there's two adapters on here. One's the built-in one called Killer, and the other's Ethernet, which is my docking station. This big old thing in the middle is a network critical smart NAXL tap or packet broker. Down here we got the big old switch, and we're going to capture things from this client going through this tap, back through the switch, through the firewall, and on the outside of the firewall, right? I've already tested everything on the inside and everything's fine. 100% of the packets get through 100% of the time. So now we want to move our test point to the outside of the firewall. Since we have two interfaces, we're going to have two trace files. So the big challenge is you can either work with two separate trace files, nothing wrong with that, or you can merge them. Both entirely acceptable. I'm going to show you an example of both. If you do want to merge them, you can just open one file and go to File Merge in Wireshark and add the other file, and it will add it chronologically. Or you can just open Wireshark with no trace file and drag and drop two trace files into Wireshark, and it will merge them automatically. The big point here is when Wireshark does that for you, it will be an untitled file, which means you better save it, because chances are you'll have some kind of error, Wireshark will crash, something will happen, or you'll just forget to save it, and then you'll be kicking yourself a little bit later. Here's an example of a working trace file, and it's merged. So one thing I do is a little bit of a standard, is I always put the word merged in the trace file name, preferably at the end. The other thing I do is I colorize the conversation, so you can clearly see this is from one adapter and this is the other adapter. Again, these are all just tips and tricks for me. You can give it a try, see if it helps out for you. The important part is if you do decide to start colorizing things, please don't go nuts, and don't forget to disable all the default coloring rules so they don't confuse you as well. Now, one of the benefits of merging the trace file and color coding a conversation is the patterns start to show up relatively quickly. So the previous slide, this is the baseline, if you want to call it that, and you can see there's a pink line, a white line, a pink line, a white line, and so on and so on and so on. And then all of a sudden, when there's a problem, bang, you see all these pink lines all grouped together. That's kind of important, so that'll jump right out at you. Now, if you had a 10 gig trace file, I'm not suggesting you do this. This is when you're trying to pinpoint something, you're trying to get your feet wet, you're trying to baseline something. This is the technique I typically use. Again, you can always work with two files if you'd like, and I'm going to show you another tip on how to better identify what part of the trace you're in. So in the previous slides I showed you could colorize your conversations. That helped a lot. The other thing you can do is add a name to the actual hosts to make life a little bit easier as well. If you don't know how to do that, just go to View in Wireshark, go to Name Resolution, make sure Resolve Network Addresses is turned on. If you do have host names on your machine or DNS, valid DNS lookups for those IPs, it'll do a reverse lookup and it'll actually populate that for you. But in this case, if you have something like 192.168.254 something, that's not really going to resolve to much. Again, unless you have an internal DNS or name server, that will do that for you. And I'm going to just go to Edit Resolve Name, and then I can input whatever name I like. So here's an example of my workflow. This is the completed product. So what do we got? We have these colorized conversations. Depending on your trace file, you could filter on MAC, IP, TCP UDP port number, application layer, whatever it is. In this case, I know I could just do a simple filter on MAC addresses to identify which part of the conversation this is. So white is from the firewall back into the network, and pink would be from the client to the internal side of the firewall interface. So you can actually see it relatively clearly. So, and I've also put the names here, firewall external, and it's going out to DNS, Google, whatever. And then you can see DNS, Google, whatever coming back to the client, so on and so on and so on. The other thing I did was I added the IP identification number, because in this case, this firewall does not modify the IP ID. So that's a great way of trying to identify what's going on. So in this case, for example, let's just jump down here, why not? The client is doing a DNS lookup for this Instagram.com. So there's a transaction ID, CB28282828, and this is the IP identifier. You can see here it says 6405, 6406, 6407, 6408. So these are like kind of internal, I'm going to call them sequential numbers IP gives every packet. And then you can see that the one that got across, this one, it finally got out through the firewall external to the internet, is 6411. So this last one got through. These did not. If I want to be 100% sure, I can just do a simple search or a display filter for these IP IDs. And I've done that, and they're not on the external side. So these made it all the way to the firewall, but did not get through, right? That's the kind of stuff people want to know. You can also take this a step further. If all of them did get through, you can start doing some latency measurements and find out how much latency the box is adding to the packets. Sometimes that's an issue with certain protocols as well. So here's an example of same problem, different trace files with the same issue. And in this case, I've got two trace files. And with this firewall, this particular setup and configuration, I know that the IP addresses will change, but the TCP port numbers will not, and the IP identifiers will not, and the MAC addresses will change. So I got a feeling for how this thing behaves. That's what I encourage you to do in your environment. Don't expect to see this in your environment. If you do, great, but you might not. So in this case, you can actually see packet 2 and 5. 2 and 5 is a TCP SYN packet, and you can see the port numbers right here. And I got the same filter down here. And I got 2 going out from the client side of the network, and only 1 getting through on the external side of the network. Again, this shows me the packet got all the way up to the firewall and didn't make it out. So in this case, 2 sent, 1 got through. There you go. And the last slide, here we go. So you've got all these lovely findings, packet trace galore. I encourage you do not just dump these trace files on people's laps with these screenshots. Unless there are the packet analysts, great, do that. But in most cases, if they're just managers, project managers, application people, your boss, do not just dump a trace file on them. Don't do that. What you do is you give them a graphical or a layman's representation of what's happening, and you can see here packets 2 and 5 left, 2 did not get through, that kind of thing. 6 came back, 1 went there, 3 went there. You can talk like that, and that way in the future you can say, hey, we made a change and now those 2 packets got through, or we made a change and it didn't make a difference, so now we're going to try this. Try to keep everything in plain terms so people understand the flow.